All right, so 6.1 is talking about the standard normal distribution. It also talks a little bit about uniform distribution, so we will go through these. The whole idea of 6.1 is to kind of show you that when you're working with a continuous variable, that the area underneath the distribution curve being, this bell-shaped curve, this is what we call the distribution curve, or this horizontal line if it's a uniform distribution, that we know that the area underneath it's equal to 1, which is the sum of all the probabilities, and if you want to find the probability of a number or less, it's going to be the area to the left. So probabilities and areas are 1 and 1. So number 2 asks us, it says a normal distribution is uniformly described as a probability distribution that is bell-shaped when graphed. Draw a rough sketch of the curve having a bell shape that is characteristic to the normal distribution. So actually what I just imaged was that. So number 2, so this is going to be 6.1, standard normal distribution. So they said draw a distribution curve that's bell-shaped. So what they mean by that is they wanted to see this bell-shaped curve. Is that better? Is it in focus? It's not in focus whatsoever. It's still not. Okay, so that's that bell-shaped curve that they're asking for. Okay. Now the standard normal distribution says that the mean is equal to 0, and then the standard deviation is equal to 1. So this would be 1, this will be 2, you'll have 3, and so on, all the way to -1, -2, -3. So it still has that idea that 95% of the data lives in between plus or minus 2. So really the standard normal distribution, the x-axis is not really an x-axis, it's a z-axis, because these are z-scores, okay? So that's your standard normal distribution. What's the area underneath this? What's the entire area? 1, yeah, the entire area is equal to 1, because that's what the sum of all the probabilities are, right? We know that the sum of all the probabilities is equal to 1. And each one of these represent a probability. So what's the probability of 1 would be this height. Probability of 2 would be this height. But the probability of being between 1 and 2 would actually be that area, right? Okay. Number 4 asks us, what does Z alpha indicate? Bless you. So if I'm asking, so number 4, if I'm asking to find, say, P95. So if I'm asked to find P95, what we have is we have that bell-shaped curve. And what I'm looking for is I'm looking for the Z-score that gives us an area to the left of 95%. So this would be 95%. So that's what the 95th percentile technically means, right? What's the area in the tail? If this is 95% and the entire thing's 1, yeah, 5% or 0.05, right? So I could write that as 0.95. Okay. So this in this case would be Z 0.05, where alpha is equal to 0.05. So when I say Z alpha, what I'm asking for is the Z score that gives me a tail of area alpha. Does that make sense? So in this case, the Z of 0.05 is the same thing as the Z-score that will give me P95. And we can find the Z-score, and we might as well do it too. Let's talk about doing it. I know I always answer more than the question. So we're done. That's the answer, okay? So Z alpha means that the area of the tail is equal to alpha. So that means you're finding the area to the left that is 1 minus alpha. So this right here would be equal to 1 minus 0.05, right? This would be Z alpha represents the Z score that gives you that particular area. So it represents one of these x-axis essentially. I mean the Z-axis. It's going to be one of these numbers. It might be. I'll tell you what. We can find it. So if I want to find P95, what I'm really asking for is I'm asking for a Z score, right? Does that make sense? Okay. So P95 is actually the same thing as asking for Z of 0.05. So in this case, alpha is equal to 0.05. So that's what my Z alpha is. So let's find it. So if I want to find P95, what I'm going to do is I'm going to go into my Z score table, right? And I'm going to look for the number that's as close to 95 as I can get. I think there is a 95 in here, isn't it? Isn't that arrow? I don't know if you guys can see it, but you can see that says, I still can't see it. Let me zoom in. I don't want to zoom in too much. I want to be able to make this thing go. Holy cow. We're just to the center of the earth, huh? Okay, so what I see is I see two numbers here. I have 0.9495 and 0.9505, and none of those are closer to 0.9500. Is that clear? That they're equal distance away? So when they are equal distance away, you actually take the average of those. So if you slide this over, you see that this is 1.64 and the other is 1.65, right? So the average of 1.64 and 1.65 is, follow that arrow down, is 1.645. Does that make sense? So that z-score is equal to 1.645. So what that means, if I have a bell-shaped curve, and I find z, remember this is the z-axis, if this is 1.645, what I know is area to the left is what? 95%, right? So this is 0.95. So you're the 95th percentile. Is that clear? So this right here is at z of 0.05. So does it make sense that, like, it's kind of like that P and Q representation, right? If P is equal to 0.8, then Q is equal to 0.2, that they add to 1. It's the same kind of idea, that 0.95 and 0.05 add to 1, don't they? So you can look at it as, hey, the tail to the right is 5%, or you can say the area to the left is 95%. So it really means the same thing. Okay, thank you. Number 15 is, asking us to find an area. So number 15 gives us this, it asks us to find, it says the graphic depicts a standard normal distribution of bone density scores with a mean of 0 and a standard deviation of 1. So bone density scores are quite literally just a z-score, okay? So what they're saying is if they give you an area, can you find the z-score? So it's kind of what we just did, right? Except I need area to the, remember when we use our table gives us area to the left, and this right here is area to the right, isn't it? So if the area to the right is 0.9265, let me draw it up. I don't want to write in the book. Exactly, it's totally right. Yep. So you're just going to take 1 minus that. So if this area right here, this area is equal to 0.9265, 0.9265, then that area you said is going to be what? Yeah, 1 minus 0.9265. So this is number 15. So this area right here was at 9265, and I'm trying to find that area right here, which is going to be 1 minus that. What did you say it was? 0.0735. Cool, 735. So the area in there is 0.0735. So what I'm going to do is I'm going to look for that number in the body of the graph, because remember this is an area. So if you look at your z-scores, let's talk about this table again. What this table represents is inside here, these numbers represent areas, and then the vertical and the horizontal axis represents their corresponding z-score, right? So every z-score gives you a particular area, right? You change the z-score, you change the area, don't you? Does that make sense? So kind of the idea is if I pick, here's a quick question, if we move on. What if I give you a z-score of 0? What's that equal to? What's the area? 0.5, right? Because all of it is equal to 1. So if you look at a z-score which is equal to 0 right here, 0.0, and you track that there, you get 0.5. Does that make sense? Okay, so for every z-score, if I have a z-score, say 1.37, so you take your 1.3, you slide it over to 0. Actually, I'm out of frame. So if you take your 1.3, which is right here, and slide it over to 0.07, this number right here represents that area. to the left of 1.37. So it'd be 9147. That'd be the area to the left. But I don't want that kind of area. I want an area of this. I need an area of 0.0735. So all these areas are going to be above 50%. All these areas are going to be below 50%. So I know I'm looking for a negative z-score. So I have, anybody find 0.75? I'm sorry, 0.735? Yeah, let's see if I can find it here. So there you go, yep. You guys see it? So it's right here, 0.735. So you said negative 1.45, right? 1.45. So kind of the idea is if it's negative, it's kind of like the addition of these two numbers. You have to be a little careful because this is like a negative number. But if they were both positive, if you added the numbers together, you would get that 1.45, right? So this is negative 1.45. So this is negative 1.45. So that's what that z-score would be. 33. So what this has given us, I don't even think it goes that far. It doesn't. Okay, so since you're doing a video on it, let me go outside of what you guys are asking, because I'm gonna ask a couple questions. So a couple examples. Determine the probability of A z greater than, z less than 1.25, B z greater than 1.25, C minus 0.54 less than z less than 1.25. Okay, so let's just answer these so you guys have a video on at least this. So what I want to see is sometimes in the book it just says less than 1.25. This is greater than 1.25, and this would be between. So depending on the wording, it might say this or it might say this, between negative 0.54 and 1.25. So depending on the wording, what you'll see is in this particular section they use the greater than, right? Wording. Okay. All right, so what I want to use is I want to use my table and I want to find these probabilities. Now remember, our table gives us area to the left. And if the arrow points to the left, that means it's area to the left, right? If the arrow points to the right, it's to the right. Okay. So if I want to find the area to the left of 1.25, I have to find 1.25 on this, right? So that means, since it's positive, that means I'm on the positive z-score. This is a z-score, right? So I need to find 1.25. So I'm going to go down here until I find 1.2, right? And I'm going to go across here until I find 0.05, right? And then you're just going to connect them together. Is that clear? Okay, so 1.2 is right there. 0.05 is right here. So if I slide across this way and down here, I get 8944, 0.8944. You guys get that too? Okay, good. Yeah, double check because it's time for glasses. Solution. So A. So the probability that z is less than 1.25. When I put probability in here, what I'm actually asking for is I'm actually asking for areas. That's what that means, okay? So the probability of z being less than 1.25 represented by the area is going to be equal to that, I lost it, I had 1.25, I have 0.8944. So again, you go down to 1.2, go across to 0.05, and then you connect these just like this. All right. Well, if I know the area to the left of 1.25 is this 0.8944, how do you find the area to the right? That's how it's done. Yep. So if you want to do area to the right of 1.25, so greater than 1.25, then this is going to be equal to 1 minus the probability of z being less than 1.25. Is that clear? That you just subtracted from 1? The reason why you can do that is because the sum of the probabilities is equal to 1, right? So this is going to be equal to 1 minus that 0.8944. Zero point 1056. Thank you. How about between? So what this represented, just to give you us a little picture, is this is 1.25, and that area to the left right there is this number right here, right? And this thing right here is area to the right. So if you have that bell-shaped curve, if this is 1.25, what this represents is that area, right? And if I want area between, I'm looking for area between. So if I have negative 0.54 to this 1.25, what I'm looking for is I'm looking for this area here. So the way we find that area is we find the area to the left of 1.25, the entire area, and then you subtract off this white area, right? So it's the bigger area minus the little area is going to give you the area between. So the probability that negative 0.54 is less than z, which is less than 1.25, is going to be the probability that z is less than 1.25, because that's going to give us our bigger area, right? Minus the probability that z is less than negative 0.54. Okay, so I already know the area to the left of this. I've already found it, right? Can you guys find me this one? Take a second. I don't want to say what it is. I want you guys to find negative 0.54 just to make sure you can do it, okay? What'd you get? So let's do it. I'm going to do it too on the video. So what I'm looking for is I'm looking for negative 0.54, right? So you're going all the way down until I find negative 0.5, which is right here, and then I go across until it's right, to the 0.04. That's what I got, 2946. Yep. So minus 0.2946, and then we just subtract.
What question is this?
It's not. I want to do a video just for you guys to be able to see, and also for the online class as well. But it wouldn't be bad to have something to reference, right? So that's what I get. I get that 0.5998. All right, now let's answer your other questions. So what 15 is asking, that's right, what 33 is asking, is it wants to know what's the probability of being less than 4.55? That's what it's saying. And if you go to your chart, do you see 4.55 on there? No, you don't, do you? It stops at what? 3.5. Yeah, 3.5. But it says anything above 3.5 is what? 0.999, okay? So that's the answer to that, okay? So for 33, because it's asking for less, right? Yeah. So let's have a look. Just make sure that this makes sense.
Oh, yeah, because it's over. Okay, I get it.
Remember how many standard deviations that is? Like 4 is a lot. You guys agree? Remember this? That z represents standard deviations. So 1 standard deviation, 2 standard deviations, 3 standard deviations, 4 standard deviations, 4.55, right? That's way the heck out there, isn't it? That tail is tiny. So what do you think that area is going to be? You guys agree that's almost all of it? So when they say when you look at this and it says anything above 3.5 is just going to be 999, okay? So that's why that's the case, because you're really basically looking at all of it. So that means the probability of z being to the left of 4.55 is going to be equal to 0.9999. So with remember that we're doing probabilities. With discrete probabilities, we do 3 sig figs, right? But with continuous probabilities, we're always going to go 4 decimals, okay? 4 beyond that decimal place, all right? The reason why is because we're using our table, and the table gives us 4, so it's a little more accurate. 39 is asking us to find... good question. So it says if bone density scores in the bottom 2% and in the top 2% are used as cutoff points for levels that are too low and too high, can we find the 2 readings that are the cutoff values? Totally. Yep. So we're going to do them. We have to do it separately, though. Okay. So for 39, what it's asking us to find is, it's asking us to find this. Like this value right here and this value right here. What it says is remember that we're doing 2%. So inside here I have 0.02, and inside here I have 0.02. Is that clear? So in the middle we have 96. I have 0.96. Is that clear? Can everybody see that? So they say they want to know the bottom 2% and the top 2%. That's what they're looking for. Now remember that our table only gives us area to the left, so we have to take advantage of that. Is that clear? So let's find the first one first. Let's find this one first. So I'm going to redraw the picture. That's a terrible bell shape. Oh well. So the area to the left is 0.02. Is that clear? Okay, so what I have to do is, this is different than what we did before. Before what we did is we did the z-score tracked to area, right? What do we have to do now? Area tracked to z-score. Yep, so we just have to work backwards. So we're looking for 0.02. I know it's less than 50%, so we're going to get a negative z-score, aren't we? So we have to find the number closest to 0.02. So, all right, so you guys can kind of see that. So, no. That's pretty good. That's pretty good. Okay, so I got two numbers here. I got 0.0202 and 0.0197. What one's closer? The 02 or the 97? Why is the 02 closer? Yeah, it's 2 units away, right? As opposed to 3 units away? When I say units, I'm talking about the fourth place. Okay, so so this one's closer. So we're going to use the closer one. The only time we're ever going to take the average is if they're exactly between each other. And the only time when they're exactly between each other, you'll see the arrows for it. So these are the only 2 cases that you'll see. Oh, I lost it. There it is. So when you track it back, what's the z-score that you get here? Yeah, this goes minus 2.0. Up here is going to be 0.05. So this is, like you said, negative 2.05. Does that make sense? Okay, how do we find the top one? Well, I want this one, right? Good, but what's this area? Remember, look at here. Look at here. Well, careful. Why is it 98? Because you have this one and you have this one, right? Does that make sense? That total area is going to be that 96 and that 2. So this has to be what again? Yeah, 0.98. Okay, so you have to, it has to be cumulative area to the left. So what I'm looking for is I'm looking for 0.9800. We won't find it, but we'll find something close, right? Tell me when you find it. You guys got it? Okay, so I see 2 numbers. I have the 9798 and the 9803. What one's closer? Yeah, the 98, because again, it's 2 units away, and this one's 3, right? What number do you get there? 2.05. Why does it match? This is 2.05. Yeah, they're equal distance away from the middle, and what's the center of this curve? 0, right? This curve is symmetric, isn't it? So it makes sense that that number and that number are opposite in sign, aren't they? Is that clear? Yeah, they're going to be exactly the same distance away from that center 0. So those are the z-scores that cut it off. Actually, if you want to, yeah, they both kind of represent. Technically, they say the positive represents z of 0.02. That's kind of what that is. It's the tail is 2%, right? Is that clear? 41 is, oh, here we go. Can't read it because my colleague wrote all over it. All right, so it says, this says z.10, right?
Yes.
Okay. So 41 is asking for z of 0.10. So I have to draw the area. What's the area in the tail if this is z.10? Yeah, what's the area in the tail if this is 0.10? That's right. Plain and simple. What's the color of a red apple? Okay, so remember that your table gives you area to the left. So this point 10 is not helping me, right? Well, it's helping me a little bit, but it's not the number I need, right? What number do I need? Yeah, I need that one, right? I need area to the left. I'm looking for area to the left, which is going to be 0.9. So the same idea is we're going to go in this table. We're going to try to find as close as we can get to 90%, and that'll be good. So 90%. Here we go. So you're going to see two numbers like 8997 and 9015, and the 97 is much closer. So when you track this back, it's going to be 1.28. So it's the exact same thing that we did here. So this number right here is 1.28. So that's what this is equal to, 1.28. I'll just talk about it. I don't have time to do it for you guys, but about what percent of area is between -1 and +1? So 1 standard deviation. So what you're going to do is you're going to find the area between. You're going to find the area to the left of 1. You're going to find the area to the left of -1, and then you're going to subtract the areas, right? So for number 45, 45 is done exactly like this example here. 45 is done exactly like this. If you want to find the area between, except they're asking not for these numbers, they're asking for -1 and +1, okay? So you find the area to the left of +1 and subtract the area to the left of -1, and then you're done, okay? And what you'll notice is it's going to be about 67%. Remember going through that, like when I was explaining 1 standard deviation, that if we have a bell-shaped curve, oh, that's a terrible 1 standard deviation. That's a terrible bell shape. Oh well. So the idea is, it's supposed to be symmetric. It's not looking okay, but the idea is the area here is about 67%, right? And then if you go 2 standard deviations, that's about 95%, right? And then 3 standard deviations is about 99%. Now, what I mean is about. You guys can find those numbers now, okay? Just use this table to tell you exactly what they are, okay? All right, so